In this video, I'll present a new node editor for the Python programming language. I'll start with basic info, then show some examples using popular Python libraries. Hello, Kennedy here. This is a Python node editor called Nodezator, made by me. I expect to release it more or less on June 2022. It is a desktop application made with Python and the pygame library. It allows users to turn their Python functions into nodes, execute them, and optionally export them as an image or Python code. It is also part of the Indie Python project, just like the Danny to the Rescue game prototype, the level editor, and the animation editor presented before. First of all, let's see it in action, shall we? Here is a simple demonstration. As usual, since node editors are used a lot for media editing, in this example I'm gonna use it to edit images using the Pillow library. First of all, let's create a text block so people who see this file know its purpose. Next, I'm gonna create a node that allows me to load an image file. I'll then navigate to the image I want to see. Now its path is set in the nodes widget and we can preview it easily. Here is a bigger thumb. And here you can see it in full size and even pan it to see it better. Well, let's do something interesting with it. Let's say that I want this image to display cool colors rather than the warm colors it has right now. I'll just mix the image with a cool color image of the same size using a soft light operation. I'll then create a node to allow me to visualize the result and press F12 to execute the graph. As you can see, we now have the cool colors we want. Let's use another node to compare the results side by side. We can also use an interactive version. Here I just drag the little widget to see the difference between the two images. I can even go back and change the axis to the vertical one. Also, remember how I said that the nodes provided by the user are just regular Python functions? Well, guess what? We can even use variable parameters, that is, parameters like asterisk args and double asterisk quarks. For instance, let me show you yet another node that allows me to compare as many images as I need. Here I'll create two more effects on the original image and compare them side by side. Well, I'm pretty satisfied with the result right here, so I'll create a node to allow me to save it on the disk. Since the path I provide doesn't exist, no preview is loaded. But once we execute the graph and click this icon to reload the preview, it now shows a preview of the image in the path we provided earlier. And here it is in my system's file manager. So how exactly are these nodes created? Well, some nodes are already included out of the box by default. However, to really tap on the full potential of the app, you are encouraged to create your own nodes from your own Python functions. Yes, all you need is a Python function and the app will turn it into a node for you. That is, it will nodezate your functions. Please, let me show you with some examples. The function on the left will result in the node on the right. This is an example of one of the simplest nodes you can create. The getFavoriteColor function will be turned into a getFavoriteColor node, which will return the string blue. It has a single output socket from where we can obtain the return value. I'll demonstrate it in action by creating a node to print the output. By providing a type hint, the socket is painted with a special color, indicating its expected type. For instance, here I indicate the return value is expected to be a string, so the socket is painted green to indicate it. Notice I'm always talking about expected type, not actual type, because no type is enforced by the hints, just like in regular Python. In this other example, though, this getFavoriteRGB function returns blue as a tuple. Because we indicated so in the return annotation, the output socket also changed its color to indicate a tuple. Now we have a similar function with an includeAlpha parameter. As you can see, if the parameter is true, the RGB tuple representing the blue color is returned with an additional integer, representing the alpha channel. Otherwise, just the regular tuple is returned. Let's try to execute it, and an error occurred. Of course, right? Because now that we have a parameter, we need to provide data to it so the function can be executed. So I'll create a data node with a boolean value and now it executes fine and returns the expected values depending on the given boolean value. That is, if true, a 4 tuple, and if false, a 3 tuple. You can probably already guess what will happen if we add a type hint to the parameter indicating a boolean value is expected. That's right, it will be colored to indicate so. As you can see, this function is almost the same. The only difference is that the input socket is now color-coded to indicate a boolean is expected. However, what if instead of the type hint we added the default value? This is the result. a node with a widget containing our default value. You can still pass any value you want. Incoming data from a socket has priority over the default value, so the value in the other node is used instead. But the advantage is that in the absence of external data, you can still execute the node by itself, since it already has data for the parameter. See? Remember, every time you provide a default value, a widget will be used to hold it. By default, that grayed out widget representing the value will be used. This widget doesn't allow the value to be edited. This is so because we need to explicitly tell the app which kind of data is expected at the parameter, so that it can try to come up with a suitable widget. So what if you wanted to actually choose the widget? How do we explicitly tell the app which kind of data is expected at the parameter? Again, we use the parameter annotations, the type hint. Whenever we provide a default value and an annotation for a parameter, the Nodezator app will try to come up with a widget to handle that kind of data, and the widget's value will be set to the given default value. Thus, if we set the type hint to Boolean and the default value to a Boolean value like false or true, the app will choose a check button to hold and edit the value, since the widget is suitable for Booleans. In this other function, the parameter's type hint is a string and the default value is also a string, so a string ent widget is picked. That is, a widget that allows you to edit the string. These other functions use widgets suitable for editing numbers. This function returns a pygame surface of given width and height. This widget is quite powerful and can handle common operations. As well as some functions for select Python standard libraries. You can type floats as well, but they will be constrained to integers. You can also click and drag to change the value, and press Shift while doing so to make the changes more subtle. This function calculates and returns the area of a circle given its radius. The widget, which uses float values, is the same one used for integers in the last function presented, but will constrain the values to floats. Oh, you must also be curious about how to make a node return more than one value, that is, have more than one output socket. It's actually pretty simple. You just need to explicitly say so in the return annotation of the function. Here's how you do it. You just need to use a list in your return annotation. Each item in the list is a dictionary that defines the value the node should return in that socket. Then you just need your function to return a dictionary where each key is one of those outputs. There's actually much more to discuss about other widgets and how to pick them, but the purpose of this video is just to present the app and an overview of its features. In future videos and documentation to be released, we will present each feature comprehensively. How about another quick demonstration? This time, we'll use the matplotlib library. I'll create a node to generate a pie chart figure. You can feed it data in many different ways. Let's start by adding keyword arguments representing different fruits and their quantities. I'll create a node to let us visualize the generated figure. We could also feed the dictionary we create. And dictum packet. Or even load a JSON file. We can also use a node to save the file. I'll just use the type value for the bounding box, so that we save a more compact version of the plot. As you can see, once we reload the preview in the widget, we can see the final image saved. We can also see it in my system's file manager. The graphs can also be exported as some useful and popular formats. For instance, I'll export this graph in HTML, that is, a SVG tag inside an HTML file. SVGs save a lot of space and can be zoomed in and out, making it an useful format for others to quickly visualize your graph in the web. You can also export as a standalone SVG file as well. And of course, you can also export as a PNG file. Last but not least, you can even export your node graph as a Python file. Here it is. This is a very powerful feature because it means you don't even need the Nodezator app to execute your node layouts. You can just export your layouts to Python and execute it directly in your own Python scripts or applications without having to import external code nor load any additional resources. I'll get back to you on that in a few moments. Let's now talk about the purpose of the Nodezator app. Use Nodezator for whenever different combinations of functions and parameters are desirable. That is, for producing parametric data and/or behavior. That is, if you have a piece of code which relies on the combination of multiple functions and their data, the Nodezator app might be useful and desirable. Use it for easy addition and visualizing of data in such context of multiple functions and parameters. Since Nodezator uses pygame as the front end, you can easily make your own widgets to make it easier to edit your data. You can also easily make new visualization nodes to make it easier to visualize the data you generate. Also use it to implement no-code approaches to workflows that would otherwise rely on scripting. Let's say that you have a very modular set of operations in the form of different Python functions, and they are pretty straightforward to use. You can easily convert your functions into nodes so that someone less proficient in programming can create and edit graphs using the Nodezator interface. Well, what Nodezator is not? The Nodezator app is not a replacement for the regular way of coding in Python. It isn't even an attempt. Python has many features and structures that are not present in the app. As I just told you, we just facilitate the combinations of Python functions and data into graphs. Let me show you what I mean by that in the following section, where I present the origin of the app. So you may ask, how did you come up with this app? The app is the result of my attempt at generating animations in my other app called Pygame, the animation editor. Here is an example of what I had to do before to generate a custom animation. Those different function calls were used to generate points that were used to position characters. If you have a lot of powerful modular functions, you can achieve a lot by just combining them. But doing this in a text editor is not always quick or intuitive. You just change the arguments, change the functions, replace one by other, and execute everything until you get the result you want. Each usage of such functions would result in different combinations. I didn't want so much code repetition to be my scripts. If using such functions just means combining them in different ways, that ought to be a better way to represent such combinations. That was when I came up with a JSON representation of such function calls. However, it really didn't help in the end. It just made things a bit more organized. As you can see, it is structured like a tree. This was the best I had to work with, and it did help, but there were still problems. I had no user interface to edit such data and thus had to do it manually in the text file, which takes a lot of time. Though more organized, this JSON tree format required a bit more repetition in some cases. For instance, did you notice we had to define the circle twice, even though they had the same arguments? That is, I had to repeat some function calls in order to generate the same piece of data across multiple branches. Just like before, this is also difficult to edit. For instance, some kinds of data are not so easy to edit in text files. Like colors. I mean, it is pretty easy to type in color values once you know them. But how to pick such values? How much red or green or blue your color has to have? A user interface would clearly help a lot. Moreover, even though I was not working with colors at the time, I knew I needed a more versatile workflow for parametric data and behaviors. This is so because I wanted to use the same parametric approach to work with other kinds of data, like images, videos, particle systems, etc. I needed something that could be used with Python for anything I eventually come to need. Not just animations, not just images. I needed a general Python approach for a graph with functions, their arguments, outputs, variables as well, etc. I already knew a bit about the Nodezator workflow from my experience with Blender 3D and a video course by Bartek Skorupa I bought online. In my personal research I came upon the inspect module, which offered a straightforward way to obtain metadata about a function signature. Then I realized the node could be seen as a function. That was when I decided to try such approach of turning Python functions into nodes. I did look for an existing solution before developing Nodezator though, but no application I found did really met my needs. They always had one or more of the following limitations. They did not turn Python functions into nodes. They did not allow the graph to be exported as Python. This means the workflow would be too reliant on the app itself, which I didn't want. Once you finished working on your node graph, and if it is all made of Python functions combined together, why should you need anything else besides pure Python to execute the node layout? I just wanted the node layouts to be sort of a different way of organizing code and nothing more. Another limitation is that they had somehow limiting licenses. And thus I created the Nodezator app, and I can use it to generate not only animation data, but anything else I might need. Here is a demonstration of the animation data generation. I'll generate a circular movement. See how smooth? This could be the movement of a flying enemy, protecting a treasure in the center. Let's say now that I want it to be a bit more erratic. For instance, to simulate some negative effect being applied to the enemy. I'll just apply some random slight variations in the circular movement. And then I have it. Development started at the very end of March 2019, but it was only possible due to 2 years worth of pygame GUI libraries I made for Danny to the Rescue prototype, the level editor and the animation editor. It took me 8 weeks to be able to launch the application and instantiate a node from a Python function. Only on November of that year, though, I was able to finally make nodes connect to each other and execute. Since then, I've only worked to improve and add essential features. Except between January and August 2021, when my work was halted due to health problems. In other words, Nodezator is the result of 24 months of development, without including the 2 additional years to develop the pygame GUI used as the base of the app. Now I'd like to discuss 2 important implications the release of Nodezator will bring considering its features. First, because the app can export the graphs to Python files, the graphs can be used in any Python application, not only in the Nodezator app. As I said before, I wanted the node workflow to not be too much reliant on the app. I'll now give you an example of how using the Nodezator app will allow you freedom to use your node layouts in your own applications without getting too much dependent on the Nodezator app itself. So, just a quick recap. The Nodezator app is just a pygame desktop application that takes your functions, turns them into nodes, and lets you organize them into node layouts, which you can then execute, right? That means in theory, that once you have your node layout, you shouldn't need the Nodezator app anymore, right? After all, the node layout is just a representation of pure Python code, the functions you created, right? Well, I have great news for you. This is actually how it is. You can export the Python code equivalent of your node graph and use it in your own applications without needing the Nodezator app at all. I'm actually going to demonstrate it with a practical example right now. So let's say that I have a Tkinter app that takes an image, a color, and lets me choose an operation to mix both, creating a new image which I can save on disk. Provided that my app uses combinations of modular functions to achieve its results, I can turn those functions into nodes, edit them in the Nodezator app, and then export the node layout as Python code that can be inserted directly into my Tkinter app. In the case of this app, the functions use the pillow library to manipulate image files. They are all stored inside this folder called pillow editing, and they are not dependent on the Nodezator app at all. They are like standalone tools that can be used wherever needed. Those functions are actually the ones I used in the pillow demonstration at the beginning of this video. So let's revisit the pillow demonstration from before. Here is the file we created. It already has all the operations we need. That is, we have a node loading an existing image, then one that receives a color we provide, and another one that takes a path wherein to save the resulting image. Like I said before, since we provided the functions themselves and the node editor just helped us organize the functions into a graph, it is only fair that we can execute the node layout anywhere we want, not just in the Nodezator app. We should be able to import it into our own applications. That is what I'm going to do right now. So I'll begin by exporting the node layout as Python. And here it is, all the functions being called, their outputs being passed along to other functions, etc. As you can see, the node layout is encapsulated in a function so that we can easily reuse it in our applications. The only additional change I'll make is to expose the inputs of some of the functions as parameters in this main function representing the entire graph, so that we can pass our own values to the functions inside. I already developed the GUI from native to Tkinter widgets. Now I just need to import the main function representing the layout and use it in the application. As you can see, the package relied on a placeholder function that did nothing. We'll now replace it by the one we generated from the node graph. Let's now test it. Let's choose the same image we used before. Then pick a light blue color and use the soft light operation. We'll save the resulting file as Tkinter app result.png. Let's then click to create the new image and see the result in my system's file manager. As we demonstrated, we only use the Nodezator to edit the node graph, and that's all. Since the node graph is just a combination of function calls, we can export it to any script or app we want, just like we did in this Tkinter app demonstration. The Nodezator app is just a general node editor that can be used by any Python library or application. Well, this was the first implication. The second one is, because the app relies on functions to define nodes, all existing Python functions can be easily converted into nodes. That is to say that your own functions are nodes, pygame functions are nodes, matplotlib functions, numpy functions, pillow, opencv, pandas, and so on. This implication is the very namesake of the app itself, Nodezator. So feel free to use it to nodezate Python functions as you need. In fact, all of the hundreds of thousands of packages in the Python package index can have their functions nodezated. But remember, I repeat, Nodezator doesn't replace the usual Python workflow. It is really just another tool for your tool belt. So when it is released, don't just learn how to use it, but also when to use it. I'd like to end this video discussing my plan for funding the next steps in the development of Indie Python project, which includes the Nodezator app and other related open source projects. In summary, I want to use a Patreon account for this, that is, obtain recurring funding however small for this project. As of now, the Indie Python project is a personal project to provide Python game dev related apps and content to help others like me to develop games and apps in Python. After all of what I presented you, don't you think this project can be very useful for the Python community? I believe people can make games and applications in Python and earn good money with them. But I believe some tools are needed still, like a proper level editor, an animation editor, a node editor like the one I just showed you, and much more. This is what I've been working on, but I currently don't have a source of income. I also want people to have access to my apps and their source code forever and for free, including Nodezator, which is why I'll be releasing all of the apps under the Indie Python project, including the Nodezator app, to the public domain. Also, rest assured, the public domain release will happen regardless of whether or not I obtain funding for their development. That is, everyone will have access to the apps and the code for free forever, regardless of donation or lack thereof. In fact, everyone will be able to access or download the apps from GitHub, or simply install them from the Python package index using the pip install command. But for those of you who have the funds, when I release the Patreon account, please become a patron of this project. There's still much work to do, things like other features for the existing apps and other needed applications, as well as open source games, so people have plenty example code to make their own apps and games. That's why I do need funding for such work. I've already thought of some exclusive advantages for patrons, but we'll discuss this in another video. I may not be the brightest person, but as I showed you, I believe I can put in the hard work. Just one more thing. Because the Nodezator app has so many applications in different fields, it will have content not only on the Indie Python website, but also it will have a dedicated website, Nodezator.com, with documentation, tutorials, etc. That's all for now. I hope this was useful somehow. Thank you very much for your patience. Please share and subscribe to my content on YouTube and my social networks.